what is the probability that I flip just one time? Like I get it on the first flip. So that would be the probability that x equals 1, right? The probability just takes me one flip. This is G. What's up, tomorrow? This is H. Here's G. The probability that I flip just one time, so the probability that x equals 1 is equal to, well, 1 minus p to the k minus 1. Well, k is 1, so 1 minus 1 power times p. K is 1, because I want to say, what is the probability I just flip one time and I get ahead? Let's find out. Well, 1 minus p is 1 minus 0.4. To the 1 minus 1 power, 1 minus 1 is just 0. Times the p, which is 0.6. P is 0.4.
Yeah.
So I have 0.6 raised to the 0 power times 0.4. Any number raised to the 0 power is what? 1. So this is just 1 times 0.4, which equals 0.4. And that makes sense. The probability of getting a heads on the first time is 0.4. That's the probability of success. Question?
Because 0.6 to the 0th power equals 1.
Questions? All right. Does anybody still need either G or H? Okay. What is the probability that I have to flip at least once? So that's the probability of flipping once, plus twice, plus 3 times, plus 4 times, plus 5 times, plus 6 times, plus 7 times, all the way to infinity. Think about it like logically. What is the probability I have to flip at least one time to get a heads?
Wouldn't it be the same equation you gave us yesterday? Just with
So hold on. What is the probability I have to flip one time to get a heads? At least one time. Think about it. What is the probability I have to flip the coin at least once to get one head? Isn't it 100%? Don't I have to at least flip one time to get a head? Don't I have to at least flip the coin once to get one heads? I have to at least flip one time to get a heads. I can't just magically have the heads appear out of nowhere. I have to at least flip the coin once.
When you take it out of the pocket, it's heads already.
I gotta flip the coin, Brian. I gotta flip the coin at least once to get a head. I can't just like flip it 0 times and get a head. You gotta at least flip once. Maybe you have to flip twice. Maybe you have to flip 100 times before you get a head. But at a minimum, you have to flip once. You gotta at least flip the coin. So the probability of flipping at least once for a geometric is always 1. You always have to flip at least once.
Unless they will have a plan.
Suddenly. No, you gotta flip it, right? 'Cause it's saying if you play the game, you'll keep flipping. You'll keep flipping. It says in the prompt, Victoria. For which one? No, I'm talking about I. We already did G. G's right here. I is 1. The probability of flipping at least once is 1. You have to flip once to get ahead. You have to. Shh. You've got to flip at least once to get ahead. You gotta flip. Questions? Like logically, that should make sense. I can't just magically get ahead. I gotta flip.
Unless you're a magician.
I gotta flip. All right. Yeah. Okay, so let's say get everybody paying attention. Not talking about something else. If you don't get it, how many times do I have to flip a coin to get at least one head? Well, maybe I have to flip it one time. I get a head right away. Maybe I have to flip it twice. Maybe 3 times. Maybe even 1,000,000 times I flip, I get a tail every time. It's possible. Highly unlikely. But at least I have to flip once. I can't just get a head from nowhere, right? I pull the coin out. I got to flip it at least one time. And this is saying, what is the probability you flip at least once? Well, 100%. You have to flip at least once. Maybe you'll flip 1,000,000 times. Maybe you'll flip 100 million times. But at a minimum, you will have to flip at least once.
So that's the probability?
So the probability is 100%. 1.0. 1.0.
Wouldn't it be undefined?
Any geometric probability that is at least once will always be 100%. Always. Not binomial. That was what I said yesterday. Not binomial, just geometric.
Can you repeat that?
Any geometric probability where it asks you the likelihood of flipping or rolling or spinning at least once will be 1.0. And that should make logical sense.
What if it doesn't?
No one talk about it afterwards. Okay. So let's plow forward to J. This is the last thing. Last two formulas, and then you're done. So on J, it says, what is the expected value? Now again, they don't give us this on the sheet. They don't give us this on the sheet. So what they're asking here, if you really think about this, what this means is they're asking the expected value of x. That is saying, on average, how many times do I need to flip until I get ahead? On average, right, how many times do I need to flip until I get ahead? The formula for this is 1 divided by p. That's it, 1 divided by p. And this is equal to the mu, or the expected value for a geometric. Because all we're asking is, on average, how many times do I need to flip before I succeed? Well, if the probability of success is 0.4, in this case, then the expected number of flips is 1 divided by 0.4, which goes on the calculator and gets you 2.5. So what we're saying is, on average, you'll have to flip 2.5 times. Obviously, you can't flip 2.5 times. So it's either 3 flips on average, sometimes 2 flips, sometimes 4 flips, sometimes even 1,000,000 flips. Very unlikely. And sometimes even 1 flip. Never 0 flips. Not possible. At least 1. Maybe 1,000,000, but on average, 2 to 3 flips. And we'll get ahead. On average, 2 to 3 flips will get ahead. And if it was a regular coin, we would have 1 divided by 0.5, because the regular coin, it's a 50% chance of getting ahead. This is regular. And this equals 2. And that makes logical sense. On average, if I flip the coin twice, 1 should be heads, 1 should be tails. For a regular coin. This is not a regular coin. Heads is less likely, so I need to flip more. Dex.
What about in a designated amount of time?
No, okay, then it's not geometric. Then it goes back to the binomial from yesterday.
Okay.
Yeah. All right, and the last one we want is the standard deviation for binomial. Excuse me, for geometric. Standard deviation for geometric is equal to 1 minus p over p squared. The standard deviation for geometric is 1 minus p over p squared. So in our example, I would say, well, standard deviation for heads is 1 minus p is 0.4 divided by 0.4 squared. I do that on my calculator.
Is that a 5?
I got 0.6. That doesn't seem right.
I'm talking about what's about a head.
Heads, like the coin, you gotta flip it to get a heads, right? This is a Greek symbol sigma. 0.6 divided by 0.16. What does that equal?
I don't like that.
3.75.
3.75. So basically the key here is determine whether something is binomial or geometric. Binomial is I tell you how many times I'm flipping. I tell you how many times we're rolling the dice. I tell you how many times we are spinning the spinner. Geometric is I ask you how many spins, how many flips, how many rolls. And once you figure out, you apply the formulas. Memorize the 2 geometric ones. Binomial, you have it. Don't worry about memorizing binomial. We gave it to you. Memorize the 2 geometric formulas. Won't be a quiz on this until next Wednesday. Plenty of time to study this. Let's start here with Brian's question.
So the geometric one, the K is always gonna be given to you, right?
Yeah. 10 flips, or like how